Today's lesson, lesson 7.6, what about other bases? Our learning target for today is I can use exponent rules for bases other than 10. That's what we want you to learn by the time you're done with this lesson today. So as we go through our lesson today, we're going to be using your workbook. So for the time being, why don't you open up your workbook to page 33. If you don't have your workbook, that's okay. You can still follow along. On page 33, you're going to see a chart that's written like this. I want you to complete the table to show what it means to have an exponent of 0 or a negative exponent. So let's take a look at what we know. We have a value row, and we have an exponent form row. And then down here, as it says, as you move towards the left, each number is going to be multiplied by 2. So as you go left, each time you're multiplying times 2. We kind of ask, well, why is it times 2? Well, the reason why is because of our base. Our base is 2. So let's think about how these are interconnected. So if we have a value of 16, the exponential or the exponent form of 16 is 2 to the 4th power. If we expand 2 times 2 times 2 times 2, so that's 2 times itself 4 times, is 16. Because 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So these two are going to be connected. So we have find our value, and then we have to do our exponent form. So what I want you to do is pause this video and try to fill in all our empty spaces. All right, so what we're going to do is we're going to start at one of our known values. I want to start at this 1/2. And they're telling us we need to multiply. If we want to jump to our next box, we need to multiply it times 2. So 1/2 times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. All right, so now let's go backwards. So what we need to do is we need to go, this time we're going to the right, but let's think of what we have to do on this. We are actually going to be multiplying by 1/2 each time. So 1/2 times 1/2 is 1/4. 1/4 times 1/2 is 1/8. And 1/8 times 1/2 is 1/16. Now the bottom should be fairly easy as we move along. So we should notice if we were moving from left to right, our exponent, our base is going to stay the same, but we're going to drop down 1. So from 4 it drops down to 3, because 2 times 2 times 2 is 8. 2 to the 2nd power is 4. 2 to the 1st power is 2. 2 to the 0 power is 1. So if you notice, just like in the base 10 when we had our 10 to the 0 power, it equaled 1. So what we can assume that any number to the 0 power is equal to 1. So now it gets a little bit different. Now we're dealing with fractions, and that's okay. So when we're a fraction, if we notice our exponents are dropping down 1 each jump here. So now we're going to a negative exponent. So 2 to the negative first, 2 to the negative second, 2 to the negative third, and 2 to the negative fourth. So what do we start noticing about these? So what is the multiplier as you move towards the right? So each time we're multiplying by 1/2. And I kind of spoke to that when we're moving from 1/2 to 1/4, so we're multiplying times 1/2, times 1/2, times 1/2. So as we move, it's half. So half of 16 is 8, half of 4 is 8, or 4, half of 4 is 2. That's our number. So it's 1/2. All right. So use the patterns you found in the table to write 2 to the negative 6th as a fraction. So let's look back at our table here. 2 to the negative 6th, and we needed to carry on 2 more jumps here to do that. But if you notice, when we get to After 2 to the 0 power, and we're going into the negative exponents, they become fractions. All right, so our answer should be in a fraction form. So how do we do that? 2 to the negative 6 power. So to write that, we would write it as 1 over 2 to the 6 power. Now what if you should notice that our 2 to the 6 power in our denominator has now become positive. So and then we find out what 2 to the 6 power is. You can type that in your calculator. It would be 64, or 2 times 2 times 2 times 2 times 2 times 2 in expanded form. You gotta do that 2 times itself 6 times. So write 1/32 as a power of 2 with a single exponent. Think of that. How many times do we have to multiply 2 times itself to equal 32? So it's going to be 5 times, but dealing with 1/32, it's a fraction, so it's going to be a negative exponent, 2 to the negative 5th power. What would be the value of 2 to the 0 power? We kind of spoke to that. Anything to the 0 power is 1. From the work you have done with negative exponents, how would you write 5 to the negative 3 as a fraction? It's going to be very similar. Let's look at what we did here. 2 to the negative 6 became 1 over 2 to the 6th power. So we're going to do something very similar. We're going to put it as a fraction. 1 over 5 to the 3rd power. Notice it drops our negative sign when it becomes a denominator. Essentially, we're taking the inverse of this. And then 5 to the 3rd power is 125. 5 times 5 times 5 is 125. And our last one on this slide, how would you write 3 to the negative 4th power as a fraction? It's going to be 1 over 3 to the 4th, and then 3 times 3 times 3 times 3 is 81. 1/81. All right, so have you noticed that the same exponent rules apply when the base is 10 or any other number? It's the same exact rules, which is really convenient. All right, so now turn to page 34. If you don't have it, once again, it's okay. You can just follow along. On page 34, activity 6.3, number 1. This is what it says. Lynn's original expression is 5 to the negative 9th. Which of the expressions in the following list are equivalent to her expression? So let's think of the word equivalent. That means it comes up with the same solution. Same answer. All right, so we have 5 to the 3rd power, all raised to the negative 3rd power. So if we remember our rules, we need to multiply, when we're having a power to a power, we're going to multiply our exponents. 3 times negative 3 is negative 9. So 3 times negative 3 is negative 9. So our answer would be 5 to the negative 9. Yes, that one is the same equivalence. Let's try the next one. Negative 5 to the 9th. So let's think what's different about this one. We have a negative, and this one's a positive. This one is not equivalent. One's negative. They're opposites. One's negative, one's positive. So the exponent is also a positive 9 in this one. So this one would look like a fraction because it's a negative. If we brought this, simplified this, it's become to be a fraction. This one wouldn't. So this one would not work. When we're dividing, we subtract our exponents. Negative 6 minus 3 is negative 9. Negative 9. So this one would work. Okay, looking at our exponents. We're going power to a power, so we're going to multiply. 3 times negative 2 is negative 6. So nope. Negative 6 does not equal negative 9 for our exponents. Look at this one. We're dividing, so we have to subtract our exponents. Negative 4 minus a negative 5, so we can say keep, change, flip. So that become plus plus. So negative 4 plus 5 would be positive 1. That one would not work. And what this LCO stands for is leave, change, opposite. So leave, we changed, and we made the 3 its opposite to be negative 3. And our last one, so we're multiplying exponents. So we we're multiplying powers. So we're going to add our exponents. -4 plus -5 is -9. -9 does match up, and the base is still 5. Yes, that one works. So those are the 3 that work. Hope you're seeing some similarities. Next one, now turn to page 36, and we're going to do number 3 together. If you don't have your workbook, that's okay. Just follow along. So it says, write each expression using a single exponent. So I want you to pause the video, try solving all these. You're going to use it as a single exponent. All right, so let's do letter A. We have the same base, a 5, so we're dividing. So we have to subtract our exponents. 3 minus 6, so it'll be -3. So subtract our exponents. 5 to the -3rd. This one, we're power to power, so we're going to have to multiply our exponents. We'll keep our base, so 3 times 6 is 18, so 14 to the 18th power. This one we're multiplying, so we have to add our exponents. 3 plus 6 is 9, so 8 to the 9th power. So when we're dividing, so we need to subtract our exponents. 6 minus 3 is 3, so 16 to the 3rd power. And our last one, it's a power to power, so we have to multiply our exponents. 3 times -6 is -18, so 21 to the -18. All right. Hope everyone got all those. That is it for today. So you'll find the practice today in Unit 7 Materials folder in Schoology. If you have any questions, feel free to email Ms. Kumber or myself, Mr. LaPlante. Have a great day.